Hi, I'm Phil Constantine. In this edition of Travels with Phil, we are traveling back in time to 1977. This is one in a series of interviews I did for a program called To the Point for Rice University. I helped to create this program, which showcased some of the brilliant people associated with Rice in Houston. This episode is with Rice professor Dr. Donald Clayton. We talk about some new space discoveries such as the age of the solar system. Dr. Clayton was a distinguished professor and member of the faculty at Rice. He was in the Department of Space Physics and Astronomy from 1963 to 1989. He was also a professor at Clemson University. During his active career, he received many honors, accolades, and awards. For example, NASA gave him the NASA Headquarters Exceptional Scientific Achievement Medal for outstanding contributions to theoretical astrophysics related to the formation of the elements in the explosions of stars and to the observable products of those explosions. He was presented the Alexander von Humboldt Senior Scientist Award, sponsored by the Max Planck Institute, by German President Karl Carstens. He was also a Fulbright Fellow, and many, many more things are listed in the description field below here on the YouTube page. One of his papers was selected as one of the 50 most influential papers in astronomy during the 20th century for the centennial volume of the American Astronomical Society. There are links to his biography and works in the description field below. I've also added images for this video, but the audio remains exactly as it was broadcast in 1977.
Recently, there have been some new discoveries as to how the solar system originated. We'll be talking about that in just a moment.
To the Point, presented by Rice University.
Good morning, I'm Phil Constantine. Along with me this morning on our program is Professor Donald Clayton, or Dr. Donald Clayton. Are you a professor, by the way?
Yes.
You're a full professor?
Yes.
You made that one, okay.
Yes.
And we may go into a program someday as to the differences between an associate and assistant and instructor and those kind of things. But you are a professor of space physics and astronomy here at Rice University, and we're going to be talking about new discoveries as to how old the solar system is. And I guess generally speaking, right off the bat, how old is the solar system supposed to be at the latest guess?
4.6 billion years old. That's a billion is, of course, 1,000 million for people that aren't used to that. Mm-hmm. It's a long time by our experiences.
How was that ascertained? Is this using the most recent data that you developed, or is this the oldest date?
This is old data, actually. This has been known for some time, that the solar system is about that old. These are ages obtained by radioactive dating techniques. One can date the age of the Earth by this technique. One can date the moon. One can date meteorites that fall into the Earth by this technique. And they tell us that about 4.6 billion years ago, a lot of things happened simultaneously that had to do with the formation of the solid objects in the solar system, had to do also with the formation of the sun, all the comets and meteorites and everything that we have here. It all happened at about the same time. This in itself is not new. What is more new are things highlighting controversies about the way it might have happened.
Mm-hmm. Well, something that has interested me is how can you actually tell that this is when things actually started, or is this just the time that you're able to measure back? In other words, do you go by, you say it's the starting because it's the oldest date you've got so far, but then again, if you'd gone back and said how old was man, it's been changing rapidly because they're finding older and older skeletons.
Yes, that's right. Well, you really asked two questions, but I think to the first one, we don't really know that that's when the solar system began. It's true, it is the oldest age that one can find, but the fact that different classes of objects, like the Earth and the Moon, and many different classes of meteorites, that they accumulated in some sort of a space environment, probably in a gravitational disk orbiting our sun, something like Saturn's rings orbit Saturn. This dusty disk, the stuff accumulated right at the beginning, and that these all have age about 4.6 billion years, and that's known with reasonable accuracy. That number hasn't really changed, unlike the age of mankind, hasn't really changed in the last 10 or 15 years very much. so that we believe that what it's dating is the beginning of the whole solar system. That's not the galaxy, it's not the universe, it's our own solar system, the one in which we live, the sun and all of its planets and peripheral bodies.
Okay, well, looking at that kind of thing, how is this actually ascertained beyond just what you'd mentioned earlier in detail? How do they actually go about and study these things? How do you know that the meteorite that you particularly happen to have is one that is from that period of time? Or what is the step you take once you've acquired one of these stones?
Well, the first thing, one will date it by this radioactive technique. You see, when a parent nucleus decays into a daughter nucleus, you can follow the buildup of the abundance of that daughter nucleus and tell how long the thing has existed. So one finds a meteorite and determines in this way that it has existed. The meteorites are the most primitive things we have in the solar system, by the way. That is, they're primitive in the sense that the rock that we look at today is the same rock that existed 4.6 billion years ago. That's unlike on the surface of the Earth, or unlike on the surface of the Moon, where we look at objects that formed in more recent history by some kind of geologic events. In these meteorites, there hasn't really been any geology. They're composed of the primitive stuff, if you will, that the whole solar system accumulated together from.
Okay, so what exactly have you been doing?
Right. Well, there are many controversies having to do with the origin of the solar system that I have been working on. They have to do with the dynamics of how it could have all come about. In particular, I have been working with, there are exotic minerals in the meteorites. These are exotic in the sense that they're unlike anything that we know here on Earth, both chemically and isotopically, and they identify themselves by their exotic nature as having formed at some other time and place and found their way into objects that formed at the beginning of the solar system. I've been working with these objects.
How have you been, where have these been coming from? Are they found in any particular location, and how was it brought to your attention, or how was it really ascertained that these were different than any particular other kinds of meteorites?
Well, the discovery that they were different was first made at the University of Chicago about 3 years ago. This was a discovery that the oxygen in the rocks, all rocks and minerals have oxygen in them. And no matter where we look on the Earth or on the Moon, and that's an interesting thing, the Moon too, we might come back to that, the oxygen in these rocks is the same normal isotopic composition that we know on Earth. It identifies this oxygen as, say, belonging to the Earth. It's our oxygen, if you will.
Just put together the same exact
That's right. Technically speaking, there are 3 different isotopes of oxygen. That means they have different masses. They all behave as oxygen, but they have masses 16, 17, and 18. Now, normally they stand in the same mix, one to another, sort of a mixture in abundance, these 3. But the minerals in these meteorites have a quite bizarre isotopic mixture. And this bizarre isotopic mixture means that they cannot have been derived from any chemistry in the solar system. They therefore are something that was formed somewhere else, somewhere outside the solar system, before the solar system existed, and were carried into the solar system as solid objects.
Now, how do you know this is part of our solar system?
Well, these are in meteorites, of course, that fall to the Earth. So at least by definition, they're part of our solar system when they fall to us. The question is, have they always been part of the solar system? You can use the radioactive dating techniques to show that they formed at the same time as all the other meteorites. And in their bulk composition and bulk mineralogy, they look like all of the other meteorites. It's just that they have within them, trapped within them, small nuggets of, I call it exotic stuff. It's stuff that came from somewhere else and was trapped into these meteorites when they assembled. We can't see this oxygen even if we had any of it on the Earth, any of these exotic nuggets. If we had it there at the beginning, we'd never see it now, because the Earth has undergone so much chemistry with volcanoes and weather and all these sorts of things in the history of the Earth that all of the oxygen that we had on Earth at the beginning is well mixed. And what one sees in the meteorites is oxygen, however, that could never have been related to oxygen as we know it on Earth. It's as if we have a proof in looking at a small stone. It carries within it a proof that it did not come from the normal solar system stuff, but was carried in from outside.
Does this have any immediate importance to the people on Earth, or is this just one more step in accumulation of knowledge that may someday pay off or may not pay off? It's just
I don't see
good to know.
I don't see any practical payoff. I think it's part of the process of mankind trying to understand the solar system in which we live. We started off by learning the nature of the Earth on which we live, and then we learned that it exists in a solar system going about the sun, and then we learned that this solar system exists in a galaxy with 100 billion other stars, and that this galaxy exists in a universe. And the question naturally arises, of all of the things we know, including ourselves and the Earth and our solar system, how did they begin? When did they begin? What is it a part of in the whole evolution of the universe? How do we fit into the picture? So I think the payoff is of that kind. It's really a philosophical payoff rather than a practical payoff.
Well, I've heard that the origin of the universe is anywhere, some people vary, but anywhere from 6 to 10 billion years. And is it not
or maybe even a little older
even
than
longer?
that.
That's what I said. It varies from where you're asking
about
people.
3 times the age of the Earth, I would say, maybe 13 billion years.
But is it not possible that at some time or another one of these pieces of material might possibly just happen to go zooming by our way and get pulled down to Earth by the force of gravity?
Yes, except that the meteorites that they're in, that these exotic minerals lie in, these meteorites are themselves not so exotic. It's just that they contain within them exotic pieces. And so the theory that I've been working on and the way that I've been working on this problem is the origin of these exotic things. I have good evidence, and I've discovered good evidence from computer calculations actually, that these minerals were formed in explosions of stars. It's a very, almost a poetic sort of result. When the stars explode, they make a giant thermonuclear explosion. It's a very terrifying thing by human standards, but fortunately they're long ago and far away. This giant thermonuclear explosion creates a lot of new nuclei. It fuses them out of lighter ones. As the explosion expands, it cools down, and in the debris it forms dust, sort of like snowflakes in space, only made not of ice, but of the normal silicon, magnesium, calcium, oxygen minerals. And what my computer calculations have shown is that these exotic minerals that are found in the meteorites are in fact dust from exploding stars that existed previously in our galaxy of stars.
Is it not possible then that, using what you said, to assume possibly in the future that all matter will be getting heavier as each things eventually slow down and go up and explode again?
Yes, it seems that we're on a one-way street where in the amount of light material like hydrogen and helium is in our universe growing less and less.
Although it is the most abundant.
It is the most abundant still. It's growing less and less and slowly being converted into heavier things. And part of the main process by which this conversion comes about is the thermonuclear explosions of stars. Astronomers see them and call them supernova explosions. In a supernova explosion, a single star is as bright as about 100 billion ordinary stars like our sun, so that a single star is as bright as the whole galaxy in which it is found. These explosions are the main venues for creating this fusion of lighter elements into heavier ones.
But there's nothing we need to worry about anytime soon as far as that's concerned, or is it?
Not so far as we know, but I must tell you that serious calculations and speculation about extinction patterns of flora and fauna here on Earth, some of these theories center on the possibility that at certain times in the past, like say 200 million years ago, there may have been a supernova explosion in the neighborhood of our solar system, and the gamma rays, X-rays, and cosmic rays can have extincted major species. This is a speculation. This is not a known fact.
There are lots of speculations as to exactly why that happened and why things just completely disappear.
That's right.
I've heard some rather interesting ones, which someday we may talk about. But so generally speaking, we have nothing to worry about. But this does appear that somewhere or another that things are getting somewhat older. And now there's more and more research is being done that things aren't quite as young as we thought they were to begin with.
Oh yes, when you look at the universe as a whole, that's true.
Well, I'd like to thank you for being here. This is Phil Constantine. We've been talking with Donald Clayton, Professor of Space Physics and Astronomy at Rice University. We hope you enjoyed the program and hope you'll tune in next week.
To the Point is produced by the Rice University Information Office at the studios of Rice Radio, KTRU, in Houston.
Thank you very much for watching this video. Please feel free to leave comments down below as long as the language is family friendly. And if you would like to subscribe to my channel, just click on the button over on the right hand side. Thank you very much.